Welcome back to Stewart Science. Here's another unedited video about how to predict ionic formulas. This is BC3 if you're in my class, which is predict the formula given the ions involved. And so in our last video and a previous video, we talked about how the same columns have the same properties. So this whole right column doesn't form any bonds. And in my class, I threw in sodium, lithium, and potassium into water so we could see this whole column right here will either explode or catch on fire when you put it in water. It has a violent reaction with water. Now, these are properties that anything in the same column has in common. They share these properties because they have the same outer ring electrons. And so if you use those outer ring electrons, you can draw them. They're called Bohr models and dot diagrams. But the end point that we get to is that anything in the same column has the same charge. So the first column will be a +1 charge. The second column is a +2 charge. The transition metals, this whole group right here, have different rules, so I'm not going to cover them. Then the 13th column is a +3 charge. The 14th column could go either way. It's a +4 or a -4, so we're not going to mess with that. It doesn't really ionize very well. It doesn't really gain or lose very many electrons often. So we're going to scratch that column out, and then the last three go descending, and they're negative. -3, -2, and then -1. Again, the last column, the far right column, already has a full outer ring, and so it is a zero charge. It will not form bonds. It won't form ions. It won't make compounds, usually. So these +1, +2, +3, depending on the column, and then -3, -2, -1, depending on the column, that gives us a lot of information about how many atoms will be involved in a reaction. So, for example, if I ask you about potassium, potassium is K. We find it on the periodic table. It's right here. And since that's in the first column, we go up and we see that's a +1 charge. So we have potassium with 1 positive charge. If I ask you about chlorine, chlorine is right here on the periodic table. That's a -1 charge for that column. So it would be chlorine -1. So the next step, what's really important to memorize, if you take no other sentence away from this video, it's this. The charges must be equal. So you have to have the same number of positives that you do negative charges in order to make a compound work. So we have a 1 charge here, and it's a positive. We have a 1 charge here, and that's negative. So this is already equal. If you have 1 potassium and 1 chlorine, those two automatically equal out, and your final formula, your final answer is KCl. Okay, I'm not going to write it again. KCl. Sometimes our charges don't immediately balance. So if I replace the chlorine with an oxygen, for example, oxygen is here on the periodic table, which is a -2 because it's in the -2 column. So we have 2 negative charges on oxygen. Now, if you look at this, our charges do not equal. We have 1 on the positive side and 2 on the negative side. So we need more positives. And the only way to get those would be to add a whole extra atom of potassium. So if I add another potassium atom, now I've got 2 on the positive and 2 on the negative, but I only have 1 atom. So the last step is to count the atoms. I have 1, 2 on the potassiums, I have 1 on the oxygen, so I'd have K. I have a hard time writing K's today. K2O. And it's behind my picture. K2O. That's my final answer. Because I need 2 potassium, 2K, to balance off 1 oxygen. It works the other way too. If I give you another example, maybe I'll give you calcium. Move it up. calcium, which is a 2 plus, it's right here on the periodic table, 2 positive, and fluorine, which is right here on the periodic table, which is a 1 negative. So I need twice as many of these to balance off 1 calcium. When I do that, I have 2 on the positive side, 2 on the negative side, so my final answer would be CaF2. The trickiest I can get would be to give you something like this. How about aluminum and sulfur? Aluminum is a +3 and sulfur is a -2. So I'm not balanced right away. I have 3 on the aluminum and I have 2 on the sulfur. So I have 3 positives and 2 negatives right now. Not going to work. So I need another sulfur. When I do that, now I've got 3 on the positive side and 4 on the negative side. So it still didn't work. I need another aluminum. And now I have 6 on the positive side and 4 on the sulfur side, so it still doesn't work. I need 1 more sulfur, and now I'm done. I've got 6 positive charges, 6 negative charges for it. Is it equal out? They're balanced now. My final answer has 2 aluminums and 3 sulfurs. So it's Al2S3. As always, this is Mr. Stewart. Keep learning no matter what.